Hello students. In this video, we'll learn about applications of Green's theorem. Here, we have to use the Green's theorem to evaluate the integral 3x minus 8y square dx plus 4y minus 6xy dy, where the C is the boundary of the region bounded by x equal to 0, y equal to 0 and x plus y. Now here, the curve C is given by the boundary of x is equal to 0, so that is nothing but the y-axis. Y is equal to 0 is nothing but the x-axis, and the line x plus y is equal to 1, so it is the line with the intercept x intercept as 1 and y intercept as 1. So this point is 1 comma 0 and here is 0 comma 1 and this is 0 0. So we need to evaluate this over the curve C, which is this triangular region. According to the Green's theorem converts this line integral about this curve into double integration. So the Green's theorem states that a line integral over m dx plus n dy is equivalent to writing a double integration dou n by dou x minus dou m by dou y dy dx. So here the Green's theorem, according to the Green's theorem, the integration over this curve along this boundary of this curve is equivalent to writing the area, the integral over the region between these three curves. So m in this case is 3x minus 8y square and n is 4y minus 6xy. Find dou m by dou y. So here 3x will be 0 and derivative of minus 8y square is 16y and dou n by dou x. So the derivative of 4y with respect to x is 0 and 6xy it is minus of 6y minus 8y square dx plus 4y minus 6xy dy is equivalent to writing double integral dou n by dou x is minus 6ay and dou m by dou y is 16 minus 16, so that will become plus 16y dy dx. So that will be 10y dy dx. Now we have to evaluate this integral over this region. Now to evaluate, so either keep x as a constant or y as the constant. So here I am going to take x as a constant. So you can note that the x in the region, in the bounded region, the x varies from 0 to 1. So the limits of x are from 0 to 1. Take an vertical strip PQ here. So the value of y at P is given by y is equal to 0 because it's a point on the x-axis. And this line, the equation of this line is 1 x plus y is equal to 1. So the value of y on the line is 1 minus x 10y dy dx. So we'll simplify this. 10 is the constant and integration of y is y square by 2. So this is equal to 0 to 1. 10 out of the integral sign. Integration of y is y square by 2 between 0 to 1 minus x dx. 0 to 1, it is 1 minus x the whole square divided by 2 minus 0 dx. So take 2 out of the integral sign, 0 to 1, 1 minus x the whole square dx. So the integration of 1 minus x the whole square is, so 10 by 2 is 5. It is 1 minus x raised to 3 divided by 3. The coefficient of x here is minus 1. So take a minus sign. 0 to 1. Put the upper limit. It is 1 minus 1 raised to 3 divided by minus 3 minus of 1 minus 0 divided by minus 3. So minus minus plus, we have the solution as 5 by 3. So this is according to Green's theorem. The solution of the given line integral is given by 5 by 3. Let us take one more example of the same type. So here we need to evaluate this integral where C is the boundary of the line y equal to x and y is equal to x square. So the line y is equal to x is the line passes through the origin. It's a straight line passing through the origin. So this is the line y is equal to x, and y is equal to x square is the parabola whose axis of the parabola is positive y axis. So this is y axis. So we need to evaluate this integral over the boundary of this. So according to the Green's theorem, the line integral over this boundary is converted into the integration over the region bounded by both the curves. So this is the curve y is equal to x square. Now in this case, m is xy plus y square and n is x square. So find dou m by dou y, which will be x plus 2y, and dou n by dou x is equal to 2x. According to the Green's theorem, the line integral xy plus y square dx plus x square dy can be written as double integral dou n by dou x. So it will be 2x minus dou m by dou y x plus 2y dy dx. So that is the double integral. 2x minus x is x minus 2y dy dx. So we have to find the limits for this integral over this region. Now to take an integral, so we'll find the points of intersection here. So the point of intersection of y is equal to x and y is equal to x square is, substitute one equation in the another one. So if I put y equal to x in y is equal to x square, it is x is equal to x square. So x square minus x is 0. So x common, x minus 1 is equal to 0. X is 0 or x is equal to 1. If x is 0, y is also equal to 0. And if x is equal to 1, y is also equal to 1. So this is 0, 0 and here it is 1, 1. So you can see that the limits for x are from 0 to 1. Now to evaluate, take an vertical strip here PQ. Any y at the point P, that is if the point P is on the parabola y is equal to x square, so the lower limit for y is x square. Any y on this line is given by x. So the limits of y are from x square to x minus 2y dy dx. So here, as these are the variables for y, so we have to integrate first with respect to y. So x constant, integration is of 1 is y. Here it is 2y square divided by 2 dx, and the limits are from x square to x. So cancelling 2 here, substituting the upper and lower limit. So that will be 0 to 1, the upper limit, which is x. So we have x into x minus x square, that is for upper limit, minus the lower limit which is x square, x into x square minus x square the whole square, which will be x raised to 4. So the x square get cancelled. We have 0 to 1 minus of this get cancelled. It is x cube minus x raised to 4 dx. Multiplying that minus sign, 0 to 1 x raised to 4 minus x cube dx. Integrating, x raised to 4 integration is x raised to 5 by 5 minus x raised to 4 by 4. It is between 0 to 1. So substituting the upper limit 1 by 5 minus 1 by 4, the lower limit are zeros. So 1 by 5 minus 1 by 4 is minus of 1 by 20. So the value of given line integral is minus 1 by 20. Thank you for watching.